Hello, welcome to today's session. My name is Elizabeth, and I'll be continuing on the AWS networking workshop. It's one of the workshops by AWS, and it's available at catalog.workshop.aws. You get to see a lot of different workshops, and this networking immersion day full comprehensive workshop is part of it. So we have been at this for like 4 weeks now, and we have covered different aspects of the networking workshop. Currently, we stopped at exploring hybrid environments. Like this is in the session of connecting from AWS environments to an on-premise server, which we simulated using an EC2 instance. And today we should continue with hybrid DNS. Ideally, we should have done this all together last week with the connecting to on-premise section of this part, but we would definitely need the infrastructure deployed. So we may need to pull it back up and configure this hybrid DNS resolving, or we can try just looking into the implementation of the DNS, even though we don't get to test it. Depends on where we go from here. Like, let's look at it. Yeah. So this is where we are, hybrid DNS. And then we'll be done with connecting to on-premise. Look into network monitoring, and most likely next week we'll proceed with advanced topics. So DNS is not something that you can do without, like when you're working with anything in the internet, or I don't know, deploying your website, whatever. You need your DNS records, you need them to be resolved by some server somewhere, and using the hybrid DNS, I would say it's, when you connect one environment to the other environment, they are connected privately, not going through the public internet. And using hybrid DNS means that both of these different environments in different servers, different networks, are able to resolve each other's DNS, questions or DNS records they are looking for without having to go through the public internet. So with the connection that you have built within them, they are able to work like all together. I would say you have your DNS server in your on-premise environment, and you're able to resolve everything that has to do with all the records you put there, everything that you have configured for your environment without having to go through the internet. So we'll be looking a lot into Route 53. That's an AWS service that has a lot to do with DNS resolution, DNS records. I mean, you could even buy your domain name through Route 53. Yeah. And yes, so Route 53 Resolver makes hybrid cloud easier for enterprise customers. I think the best thing for me to do first is to open this Route 53, then we can talk from there. I need to refresh this. Sign in again. And then we can move from there. Yes, this is Route 53. So when it comes to this is hosted zones, then you have the resolver where you have your rules, your inbound endpoint, outbound endpoint. These are some things that you get to look at. But with this theory, when you're talking of your network content delivery, it's part of one of the services that are related to that. And mostly when you're using Route 53, what you end up looking at is maybe your registered domains in Route 53, or you're looking at hosted zones in Route 53. All of them, this is like important in managing your deployments. But now, when AWS says that Route 53 Resolver makes hybrid cloud easy for enterprise customers, they're essentially saying that in a situation where you have your on-premise setup, you have AWS setup, like you have different environments that need to still stay in sync without going to the public internet, you're able to use Route 53 Resolver to set up the query resolution for your DNS across your entire hybrid cloud. Ordinarily, maybe you're able to, set up your DNS server and, do your DNS query resolution like in your local environment, and then you're also able to do the resolution of your queries in your AWS environment. But now when you connect these two environments together, having them being able to even resolve queries across all the way to the on-premise, even when what you are doing is from the AWS environment, and is able to, resolve the DNS queries that is residing maybe in your local DNS server or something. That is, I don't know, a step higher than just handling it separately. Yeah. So that's what we're looking into today. Hybrid DNS. Hybrid domain name systems. You can create DNS endpoints. You create the conditional forwarding rules, and then you allow the resolution of these DNS namespaces between your data center and your AWS VPCs. That's like a high-level view of what it entails. Now, I don't know if you were here last week, but okay, not last week. I think it was 2 weeks ago when we did the last session. It's available on the internet, but we simulated connecting AWS environment to the premise data center using like EC2 instances in the AWS environment as if they were just random servers. And we set up like the private connection, site-to-site VPN connection between these servers and our VPC servers. And when we deployed that, one of the servers that we had was a DNS server. I'm coming. I should be able to open the. Let me check this. I want to open the architecture so that we look at it together as we're talking. Connecting to on-premise. Yeah, I think this should be it. Is this it? Yes. So when you look, how do I zoom into this? Let me see. It doesn't make a difference if I zoom in more. But yes, in this on-premise data center, like this is where our on-premise data center is, even though we were simulating this in a separate VPC environment in AWS. Here, one of the servers that we have here is a DNS server. We had one server that was the customer gateway device that was residing in the public subnet. Then we had two servers in the private subnet. One was a DNS server and one was the web server app that they're running and deploying. Now, this DNS server is what we are using in question today. Yeah. So, seeing as, let me go back to the EC2 instance environment. There's nothing there because I put everything down. Yes, everything is 0. I was thinking if they have the code for the end solution for that, we can deploy it and just continue from there. If not, then we will just look into hybrid DNS without actually using this exact situation, because it's going to take us all the time we spent last week to redeploy this again. Yes. And we have, let me check, just hybrid DNS. Of course, on establishing. Yeah, so they're continuing from where we stopped last week without providing the documentation for us to deploy a template that has exactly what has been deployed up to this point. So without doing that, we would just explore all the things that we're doing here today without having to connect every single thing the way they did with the existing instances. I apologize, but yeah, we couldn't leave it running all along. And so for this exercise, this is where I'm going to read out to you in case, let me see if you can see it clearly. Yeah. For this exercise, we'll focus on establishing DNS resolution from AWS environments to the simulated data center. And one thing to note is that you can also establish DNS resolution from the data center to the AWS environment. It can go both ways. So this session we're having today, going through this particular document, is going to focus on the one-way resolution from AWS environments to the data center. So we're doing 53 resolvers inbound DNS queries that are continually forwarded from an on-premise data center. So this is just, talking about what we're going to be doing, which we'll see anyway. And on to it. Configure a Route 53 resolver outbound endpoint. Remember, we said we're going from AWS environments to the data center. That's why we're working with outbound endpoint. But there are also inbound endpoints that you can configure. That's what we're reading just now. That allows the opposite direction also. So you can configure both ways. We are in Route 53. Let's go back to Route 53. We were there before. And not hosted zones. We're not using hosted zones. So we're using outbound endpoints, resolver endpoints. Yeah. And Route 53 resolver uses these endpoints to communicate with external DNS servers. I don't know if you know what ENIs are in AWS environment, but they're elastic network interfaces. And it's like a network interface that you have on any of your gadgets, really. But your elastic network interface makes it like, okay, you can easily detach it from somewhere and attach it to somewhere else. So we use elastic network interfaces with our EC2 instance. You can attach this network interface to another EC2 instance, something like that. So we see network interfaces in different AWS services that we are using. And here we are told that an outbound endpoint in 53 resolver is also an elastic network interface. So if you know what elastic network interface is, it's easy for you to just like draw that parallel between the two and see how it works. So this elastic network interface, normally in AWS environments, they have their properties that you know that, okay, this is what a network interface is and this is how it is. So when you see some services, you identify it, you know that, okay, this is using an elastic network interface and this is the behavior that I expect with a network interface. One thing is that elastic network interfaces are usually associated with a VPC, like it's bound to a VPC, I would say. Is that the right way to put it? But yeah, like I just want to digress a little and show you elastic network interface. There's somewhere you can actually see a list of all the network interfaces that you have. Is it here? Let me see. Or it would be in the VPC, but let me just search it. Elastic network interface. Network interfaces. Yeah, that should be it. So, like I said, it's like a standalone thing that you can attach to different places or use in different ways. That's why it's elastic. Wherever I see elastic in AWS, have the idea that you can easily reuse it or move it from one place to the other. But the thing is, network interfaces usually have let me see, select which subnet is going to be in, which you have to, of course, a subnet is associated with a particular VPC and all that. So it's a networking component in a VPC that represents a virtual network card. I think that's the very clear way to put it. So yes, it's always in a VPC. It's a VPC resource. Back to what we were talking about. So it has yeah, so this endpoint is a network interface, an ASIC network interface, and it has connectivity to an existing DNS server. Yes. So your DNS server may be running in an EC2 instance, may be running in on-premise DNS server. It may be, but the point is, it's something that you have access to. Your on-premise server, you can already connect your VPN, connect your your DC, that's the direct connect, whichever way. But a DNS server that you have connectivity to, that is what is required. Endpoint is a network interface that's connectivity to an existing DNS server, and that's how it works. So this particular situation is based on the expected environment that we have, which is the architecture I showed you, where there are 3 VPCs for our AWS environment, and we have connected them via VPN to our simulated on-premise data center. We just transit gateway. You can look at the setup. Everything was done. You can check it out in the previous what do I call it, videos that are on this account, and any of them can be used for the endpoints. This is because those servers, those VPCs, I think also they are connected to each other. I will have to go back and check to be sure. But the point is, you can use any of the VPCs to deploy this endpoint we're talking about. Sorry. So this outbound endpoint that we're trying to create will create two interfaces. No, we create interfaces in a minimum of 2 availability zones in the VPC, and this is for high availability. So remember, I said it's a network interface, and normally when you create a network interface, you pick which subnet it should be in and all that. But the point is, when you create this endpoint, it creates the interfaces in at least 2 availability zones in the VPC that you choose. And this is how it works. Yeah, this is a picture of what it looks like. Okay. So create outbound endpoints. That is where we are at. Now my deal with it is that right now, yes, we'll continue, but if we get to a point that we can't actually follow exactly what they're doing, so I will just show you what is done in AWS environment, because we have pulled down this exact setup that was created, of course. So we are not expecting to build this hybrid DNS and get it working, but we are going to explore how it's done and look at what it looks like in AWS environment. Okay, so let's go. And if you are following this session, having just come from completing the other one without pulling it down yet, then you should be able to get this working as is without any issue. So when you want to create your outbound endpoint, you go to 53 and you get this outbound endpoint under the resolver drop down here, and you click create outbound endpoint. That's where we are here now. According to them, you put in the endpoint name, networking day outbound, and you select the VPC. Right now, we don't have any VPC in our environment, so we can't, that's why I said we can't actually create it. So you select the VPC. You can use VPC A, B, C, anyone actually. And you select the security group. So this security group is what is going to control the access. Point you need to know is that when you select this, you are unable to change the security group for the outbound endpoint after you've created it. So you will need to, maybe create another outbound endpoint if you want to change the security group. You can't change it after. And what else? You have to select your endpoint type. There are IPv4, IPv6, IP address types, and you have to specify which type your endpoint is going to be supporting. You can use IPv4 only, you can use IPv6 only, or you can use dual stack, which supports both IPv4 and IPv6. Normally, you want to use IPv4 or dual stack. It's not wise to pick only IPv6, at least not at this point of time in the internet, because IPv6 is not yet really widely used or supported by every single thing. So choosing only it's not. But yeah, you can use a dual stack or IPv4. But following our use case, using IPv4, and then you have to choose which IP address. Like here, you have to choose the availability zone that is going to be in, and the subnet and all. You can actually have more than one IP address. Remember that we said that it's going to create at least two availability zones. You can have more than that. And one thing I didn't mention with elastic networking interfaces, which I think is important to note, is like anywhere you see that, okay, this AWS resource is using a network interface or something, then you can be sure that there is IP addresses involved. The network interface is like your network, it always has an IP address somehow. So whenever you're planning your VPC environment, your network, you have to kind of account for or budget, okay, how many IP addresses we need to provision or enable in this networking environment. Take note of the AWS resources that actually are using network interfaces or anything, because they take IP addresses. Just know it. Yes. So it may not be obvious, like, okay, I'm assigning IP address to this resource. No. It may not even be a server. No. But if it's using a network interface, then it's taking at least one IP address. Okay? Just so you know. And you'll not be surprised when your IP addresses are not enough for all the things you budget for it. So back to where we were. Yes, we're talking about this. Okay. Yeah, protocol deal 53. Just stay with that. IP addresses. To improve reliability, you use two IP addresses. You can have more than, but two IP addresses is enough. And they should be in two different availability zones. And what else? I think that should be all. You create your outbound endpoint, and then that is it. Let's look at what they have. They had the same creation that we were discussing just now. Yes. Okay, there's one thing here that they highlighted with the arrow, like selecting that you should use an IPv4 address that is selected automatically. So what happens in this situation is that it assigns automatically from the pool of available IP addresses you have in your subnet. The alternative will be for you to specify an IPv4 address by yourself, but you have to take note that whatever you're specifying actually has to be available in your subnet. It has to be an IP address. You cannot just, pull one IP address out of the thin air and put there. It has to be within the range of the IP addresses available in the subnet that you specify. Okay? So you submit that, and then you create the endpoint. When you do this, you actually have to wait a little for the endpoint to be in operational mode. So you'll see that the status would change to operational. I don't know if you can see. I don't know why you can't really zoom into pictures in this networking workshop thing. But yes, the status has to change to operational before you can actually even use it. So we have the outbound endpoint that works. And one thing you note is that this environment that we have created, I don't know, hypothetically with this outbound endpoint, it's actually in a VPC, in an environment that is already connected to the on-premise endpoint. Like it's connected to the on-premise environment. So it's not just, a random environment you create outbound endpoint and suddenly it is resolving it. there is already a VPN connection between these two environments. There's already the hybrid connection there. Now we are only trying to also add an outbound endpoint that will allow DNS resolution across these two environments. So it's like an add-on to an existing hybrid connection. Note it, you cannot just create an hybrid DNS standalone. You have to have your hybrid connection between the two environments already set up, and then you are creating this outbound endpoint in the AWS environment side of that hybrid connection. If you want it to be connection DNS resolution from the on-premise to the AWS environment, you would create an inbound endpoint in this AWS side of your connection. But whichever way, you need to have that base level, that foundational that foundational hybrid connection already via VPN, via direct connect, via whatever way you want to do it, but it has to have a connection already. If not, creating this outbound endpoint is useless. It has nowhere to go to. Just saying. Okay, so you have your outbound endpoint. It's working, it's operational, and now you have to go and create a resolver rule for whatever, I don't know, here we have example.cop. You have to create a resolver rule for whatever it is that you want to be resolving. So you go to route 53, still under this resolver part, that's the last drop down in your side navigation. You will see rules there. That's where you're going to. So we know what VPCs are, we know what inbound endpoints are, we know what outbound endpoints are, and then go to rules. Under rules, you're meant to create a new rule. Let's look at what we have here. We're creating a route 53 resolver rule for example.cop. I think that's the URL that this sample corporation we're working for has as their domain name, and it's already configured and set up in their DNS server. They already use it locally or something, but we also want all the deployments we are making in the AWS environment to also be able to resolve queries for example.cop. So we're meant to create a rule here, and let's look at the particular setup that you want for it. So the thing is, whatever that we do here, the rule that we create, we're going to have to associate it with the VPCs that we want it to work with. And let's look at this. So they want us to set the name as networking day rule, and the rule type is always forward. Whatever is there, we're going to forward it to the DNS resolvers in the network that we're working with. And domain name, you put what you want to resolve, which is example.cop. That's what we're resolving. And what this says is, anytime you see this domain name example.cop, then we want to use this rule to forward it, and we're going to specify all the things that we are doing here, like outbound endpoint we want to use to resolve this and all that. Okay, so VPCs that use this rule is important for you to set up, because you could create a rule and you don't have it associated with the right VPCs, and it's not going to work for them, because for any request, any traffic in any of these VPCs to correctly use this resolver rule, you have to associate it with those VPCs. Now we don't have any VPCs, so we cannot even try associating them, but you must specify it here. Don't forget, even though it's optional, it's important for you to do that. And then you set the outbound endpoint to what you want it to be. And when you set the outbound endpoint, you're going to have to set your target IP address. Now, this is the point where you specify where they are going to forward all these traffic, all the requests that you need to resolve. This is where you specify it. You put the IP address for your DNS server. Now we're not able to see that, of course, because of we don't have it set up here. But those are the main things. I think setting up a V3 resolver, I would say, is the most straightforward part of it. What you need to do, set up your endpoint, which is pretty straightforward, and then you come and set up the rule. For the rule, the thing that you need is the domain name and the IP address of your target, your DNS server on premise. You put it there and you specify the VPCs that you want it to be associated with, VPCs that use this rule, and then you are good to go. So when you're done with that, you click submit and you have it working. I think we're done with this. I wish we could actually deploy it, but if you want to try it out, you can try it out and then ask questions or drop any comments that you want. But I thought, because it's pretty straightforward, it's not a thing that we should spend the whole time trying to recreate the entire infrastructure, because we need the base DNS hybrid connection from our AWS environment to our simulated data center to be able to even set up the DNS hybrid. We need the we need the VPN connection between the data center and our AWS environment to be able to set up this DNS hybrid resolving. So when you're done with this, you click the submit and everything is set up. And with those VPCs that you have associated with this rule, anytime they see this domain name that you specified here, they are going to use this rule and forward it to the IP address that you specified as the target DNS server, like your target IP, using the outbound endpoints that you set up here. And that's all. So this is what it looks like, the architecture here. This is what it looks like. So whenever you have any request traffic that is going for this particular domain name, it's going to use the resolver endpoints that you deployed, and it's going to forward it to the data center in the environment exactly this way. So transit gateway is going to use this, and then it's going to use the VPN tunnel to forward it to the DNS server in the corporate data center. That's your simulated data center. And that's all. Yeah. Okay. So this is information on testing it. You could try running it, and it will work. Yeah, this is it. It's just instructions on testing it. But I think now we can actually proceed with the other part of our networking workshop. We still have 20 minutes. Let's see where we can go. These instructions on cleaning up everything that we deployed in this particular module. We should have done everything together and deleted it at once. But if you haven't deleted, make sure you delete, because you have resources that are going to cost you money running in your environment, especially all the EC2 instances that were deployed. You don't want those ones running. Now, network monitoring. Okay, so this is the prerequisites. We need to deploy this in our environment to get on with network monitoring. In this particular environment, we are going to try, generating some traffic, and then we're going to be looking at the logs. How are we going to get the logs? Everything that we need to do around that is what we're going to be looking at setting up. So we need to deploy some things in our environment, and then we'll configure our monitoring, and then we'll see how the logs look like. Now, we need to first complete the prerequisite section in the beginning. That's to deploy this in your own AWS account. I'm going to redeploy all these things for us to continue with this place. Downloading the CloudFormation template again. And then I'm going to deploy it in the AWS console environment. So as usual, I'll go to CloudFormation. I saw it just now. Yeah, this is it. I'm going to CloudFormation, and as you can see, there's no stack here. I'm going to create a new stack with new resources. I'm going to choose an existing template and upload a template file. Then I'm going to choose the template file, which should be this one. And then I'm going to deploy it. What stack name? Let me see. What stack name? Networking workshop prerequisites. So that's what I'm going to name it as. There are no parameters. I'm going to use this role. I'm going to leave everything else as is and deploy it. So it usually takes some time for CloudFormation to deploy things, but after this particular template is deployed, this is the foundation networking workshop prerequisites. I'm also going to deploy let me close this one, this CloudFormation template that is for our VPCs and transit gateway setup that we are going to use. So I'm going to also download that one again, and when our CloudFormation template here is done deploying, I'll deploy that. But while we wait for that and waiting to deploy it, I would like us to proceed with the rest of the conversation. Let me just go to okay. So this is what we're going to be deploying. Just the 3 VPC A, B, and C, and the transit gateway, along with everything that is deployed inside them. We have an internet gateway for each VPC, here, and here. And then we have a NAT gateway. This is a NAT gateway. This in each VPC public subnet. We have security group here with an instance, and also a security group here with an instance. We just have some things set up here. So we have transit gateway, and we have transit gateway attachments in each of them. So we're going to have some useful networking resources deployed here that will generate some traffic for us. But let's look at what we have. It's still deploying. While it works, we can continue. So CloudWatch, I think there are 2 particular things here that we're going to be looking at: CloudWatch and VPC flow logs. Honestly, I don't expect that we'll be able to get through everything here in the next 20 minutes, but I'll try my best to see how far we can go and how fast. I just need some things to really deploy for us to keep going. But yes, so AWS CloudWatch. This is one AWS service that you cannot do without in the AWS environment. It's the main metrics service in AWS environment. Almost every single AWS service has some form of connection to CloudWatch, where you can, set up and collect your metrics and monitor them in AWS CloudWatch. Is it your EC2 instance? Is it your Kubernetes services, your container services, your Lambda function, serverless functions? Almost everything I can think of can be monitored in CloudWatch. I think even S3. I know S3 has a storage gateway, storage lens, but CloudWatch is important. And You can set CloudWatch alarms. You can set like some notifications and all that alongside just configuring your dashboard in CloudWatch and all. But CloudWatch, you want to get familiar with it. You want to know how to connect your metrics, centralize them in CloudWatch, have your specialized dashboards. Like, okay, this dashboard, I want to arrange it in this particular way. These are the things I want to be checking in this. You want to get familiar with it. So we'll be looking at some metrics for networking that are available in CloudWatch and what to do with them. So we're looking at automatic dashboards. Yeah, I think this is my favorite one, the automatic dashboards, because sometimes you want to get started looking at a particular service and you don't want to start, configuring, okay, each chart, like, okay, this is what I want here. You just go to automatic dashboards and you're able to select, okay, EKS, that's Elastic Kubernetes Service, like EKS automatic dashboard. I need to bring all important metrics for EKS for you to see. That works fine. At least for me, it does. For a lot of solutions, it's just what you need. So we're going to go to the Elastic, to the automatic dashboard. I'm going to look at it. Okay, this stack is done deploying. Please allow me to deploy the new one also before we continue. So I want to create a new stack, choose an existing template, upload a template file. I'm going to choose the one that I just downloaded, this one. Create all VPCs and transit gateway. I'm going to deploy the exact same way I deployed the one we just looked at now. Yeah, I need the name. What is the name? I need the name of networking. Yeah, networking workshop, multiple VPC and transit gateway. The parameters, I'm using my region, EU Central 1A. That's the only reason I'm changing it. EU Central 1B. And my participant IP address, I also need to set that. So I'm going to check ip.amazon.com. And it's going to give me this. That's all. Next, I'm deploying it. My parameter, I didn't put the /32 mask. I'm just going to go back and set that /32. /32, when you check that CIDR range, it's only one IP address, but it's important in this situation to actually put it, because so it's deploying. And we can go back to what we were saying. I was saying that we're going to go to CloudWatch and look at automatic dashboards. So I'm searching for, where is it? CloudWatch. You can always play around with CloudWatch, but I must say that you should be careful playing around with CloudWatch, because depending on what you set for your CloudWatch logs, you can collect CloudWatch logs. It can be costly to just be storing logs over time without deleting them or setting them to be limited or something. Don't just collect logs and keep them. It can get expensive. So you are in CloudWatch. See the dashboards. You can have your custom dashboard. You can create a dashboard. We're looking at automatic dashboards. So for different services, I think there are just few of them, but the important ones are here. Yeah, okay. So let me see which one we're looking at in the networking workshop. Click automatic dashboards, and we're looking at VPC NAT gateways. Okay, VPC NAT gateways, where are they? VPC NAT gateways, let's look at it. Here we don't have any data because there's no traffic going on in our environment right now. but this is what the automatic dashboard for VPC NAT gateways look like. And as you can see, they are well labeled. Let me try and increase this. They are well labeled that you can know what each chart is monitoring. We have active connection count, of course, active, how many active connections. And here you see like it's actually checking for the maximum, not the sum. So you need to look closely at what that chart is actually checking. Don't just assume everything is the sum. Some is like most of them are just checking for the total amount, yeah. But some of them will be giving you values on maybe the minimum connections or the maximum or something. But here we have packet drops count, some bytes in from this. This is just some metrics. Let's look back at our workshop. So we have automatic dashboards, VPC NAT gateway, and it will show key network metrics for your NAT gateways. For us currently, we don't have any traffic, so our chat is looking empty, yeah. But that's what we have there. I'm coming. I want to check, is our deployment completed? Okay, it's completed. Everything is deployed. Then let's see. We still have no data available for our time range. Here you are also able to, modify what you want to monitor. I found this very, very useful, especially in dire situations, like you are in the middle of an error, something in production is going wrong, and you really need to check a particular time range, not the past 1 day, past 3 hours. You're able to check very, very detailed here. So you can change the time zone. I usually switch it to my local time zone because by default it is usually the UTC time zone. That's what they call this thing. I can't remember it, but UTC is the one that you have to, every other time zone is calculated related to UTC. So my time zone, I think, is UTC +1 or UTC plus 2, depends on whether we're in summer or not. And putting it in local time zone just makes sure you don't mix up your time frames that you're looking to monitor. Local time zone, here you're able to select, okay, looking at your absolute time zone gives you absolute time, not relative to any other time. We're looking at May 2025. We're looking at 25th of May 2025 at so time to so time. Like, you're able to specify the exact date, time, and all in absolute. That can be useful to check for a specific point in time. But relative is relative to now. Okay? Yeah, calculating this time relative to your current time. And you're able to say, okay, I'm going to check for the last 5 minutes, last 45 minutes, the last 3 hours, the last 5 days, the last 2 weeks, all of that. You're able to check relative to a particular time. So that's how this works. I think there's nothing much to see here except when we generate traffic, which I'm sure we still don't have traffic. Yeah. And let's go back. No, not here. Okay. We can move from automatic dashboards to custom dashboards. So, creating a custom dashboard, we are going to be looking at the network metrics for one particular server. And now we're looking at how to actually generate the metrics for that server. Now we're looking at custom dashboard. So we're going to the CloudWatch console and we're going to all metrics. Let's go. I think it's good to put this on the side so that we won't be switching back and forth like this. I just need a better way for you to view everything. Yeah, it doesn't really work. But yeah, we'll make it work somehow. So we're going to all metrics here, under metrics, and we're going down to EC2. really small. So we're going down to EC2. I'm going to click it. So per instance metrics, that's the only option here anyway. So I'm clicking per instance metrics. And then we can see a lot of metrics. Now the issue is the frame that we have for this is really, the space we have for this is really small. Let me make this smaller so that we can just really see everything together. Let's try and increase this. Yeah. So these are different instances that we have. And the way it is listed, it's not that one instance, all metrics, like all the instances and all the metrics possible for each of those instances are listed here. So it looks like a lot, but it really is not. If you try to filter, okay, by one instance, you see like, okay, for one instance, you have the EBS write-ups, EBS write-bys, EBS, like so many different metrics for this one instance. And then you go down, you see so many metrics for another instance. So it's a list of combination of instance and metrics. And it just puts a list of all of those options. So here we're going to be looking at the metrics that have to do with network only. That's what our focus is. So I'm typing network, and there are only, I think, network in and network out. Yeah, network packets in, network packets out, network. These ones are the ones that have to do with network. So we're searching, and we're going to pick the network in and out for the VPCA private server. Let me see. There's no name specified. Okay, there's name specified for this one. So VPCA private AZ1 server, we're going to be selecting the network in and network out for this one. This is it, these two. We're going to be working with this one, and with this selected, we're going to change the name of this. And we're going to put the name of the graph that we want it to be. We're putting VPCA. So this is how to create a custom graph that you want based on the metric that you want to see on it. So VPCA private AZ1 server, network in, out. I find this interesting because by default there are some that you won't be able to see without creating your custom metrics. Like trying to see the network in and network out of a particular server on one graph is not by default set up that way. You usually have a network in for server separate or network in for multiple servers together on one graph, and then you see network out for multiple servers on one graph. But trying to see the network in and out on a particular graph, you have to create it by yourself. So there are situations like this that call for you to have your custom servers and your custom metric graphs, and this is how you create it. You go to the metrics, you select the metrics that you want, and then you name the graph, have it created. Finish. So the actions, we're going to add it to dashboard, and the dashboard, we don't have a dashboard yet. We're going to have to create it, but that's not an issue. Just want to get the name of what we want to create. Yeah, so we're going to name it this. We're creating a new dashboard. Remember that we had automatic dashboards. Yes. Now we're creating our own new dashboard with this, and we currently have only one chart. So click it, and then we have the line. Is there anything else? Yeah. Create, and then we need to add this. So this is our dashboard, and we currently have only one chart. We currently have only one chart. I'm going to make it a little bigger since we have only one chart. You can resize and make your chart, your graph or your dashboard the way you want it to be. So we can add more charts to just go to metrics, select whatever you want to add on your custom dashboard and fit in. And it does not have to be only from instances or anything. You can try to create a custom dashboard like this using different metrics from the resources that you are working with. So it can be your EC2 instance, it can be your network flow log, it can be your, what do you call it, your S3 bucket, it can be anything. Yeah. Okay, so what else? We're having this. Let's add another metric. In the add widget, we're going to select what we want. We want to add a number. So there are different things you can add. It does not have to be only like line charts. You can add a data table for different values. A lot of people don't get to explore the custom dashboard. Even I mostly don't work with custom dashboard, but there are times you want to present your metrics or your current results or data to, I don't know, management or something, and it gets good when you know your way around this. So we're going to add a number. You can also use gauge. You can use different kinds. It's pretty. So we're using a number. And what we want to check the number of is you can filter for the metrics you want. I expect it to still be in EC2. And we're going to be looking at network packets. Yes. So EC2, we're going to check per instance metrics. And we're going for network. We're going to filter the metrics for network. What we want is the network packets out and in for VPC A1 private server. VPC A is a one server. Network packets out, this one and this one. So I'm going to go for it. Oh no, this VPC B. I need VPC A. Let's go back up. VPC A is a one. Yeah, this is it. Network packets in and network packets out. These two. So this is what it looks like. I think it's pretty, even though our numbers are not yet plenty enough. But we're going to create this widget. Let me see. Here to put it like this. I want it to be pretty. Okay. Network packets in, network packets out. And we add that and we save. So this is what our networking workshop dashboard looks like right now. And I think it's pretty for something we created like by ourselves just now. Now, we've learned how to create a custom dashboard to add metrics that we want to track in it using two different types of visualization. And we want to create an alarm. So in our console, we open this our side stuff. We go to alarms, all alarms. Currently, all our alarms total to 0. And we're going to create an alarm. We have to select the metric that we want to track. The alarm we're creating is, let me see what we're creating an alarm on the network in. You can see here. So click select metric and we filter the same way we've been filtering. We go to EC2. We're checking per instance metrics and we're searching for network in. That's what we want to filter on. So we're doing VPC B private AZ1 server. Yeah, that's what we are monitoring for network in. I'm going to select the metric. See it. So the metric name, this is the instance ID. And currently the statistic we're checking is average. Remember that I said don't just assume that everything is working with the sum. Sometimes it's monitoring the minimum, sometimes it's monitoring the maximum, sometimes it's monitoring the average, like this one. And we need to check, okay, what conditions are we using? Now for our alarm, we want to monitor the maximum. I don't know if you can see it here in my maximum. We want to monitor the maximum, and we want to check 1 minute period. So we're going to have to change this from average to maximum and 1 minute. Knowing these different statistics and how they affect your particular metric can help you determine the best one to set for alarms or monitoring and all. Sometimes you want to be monitoring the average. Sometimes you want to be monitoring the minimum. Sometimes you're monitoring the average, but you want alerts set for the maximum. Yeah. So the threshold type is the static. And we have said that whenever network in is greater than this value, 100, 1 million. Oh, that's some interesting number. 1 million. Now, the difference in static and anomaly detection is that static, you specify the value that you want to get alerts on. As we are doing now, that, okay, if this network in is greater than this or is lower than that, then send an alert. You set it. You are the one that defines it. But with anomaly detection, it uses a band as the threshold. Like, okay, this is the range that is usually okay for our network. This is the range we are usually okay in. Anything outside of that, please set an alert. That is not static enough, I would say. And you don't have so much control over, like, okay, this is what I define as a good threshold. So we're working with the threshold type as static, and then we do the additional configuration. No, not this. Yeah, but we don't have anything set in the, yeah, we're not setting any additional configuration. And then go next. In the notification, we are using a topic. Let me see. In alarm, where's the topic? Okay, yeah, networking workshop alarm topic. So what happens is there's an AWS service called SNS, a simple notification service. And SNS is the AWS service that you usually use in your cloud deployments for notifications. There are ways you can configure it to send email, to send SMS, or like, it depends. But the point is, the way SNS is configured, you have SNS topics that you connect, and whenever there's an update in a particular SNS topic, it follows whatever you have defined there. So our alarm state trigger is when we have in alarm, like when that threshold stuff is crossed or something, then it would send a notification to the SNS topic that we specify here, and then it goes from there. There are options here, as you can see with your alarm state trigger. You can say that, okay, whenever the metric is okay, send a notification to me to, like, okay, it's okay. I don't know why. But one other part that you may want to set alarm for is when you have insufficient data. For some workloads, that is already a cause for concern. Like, when you don't have insufficient data, that means some things are not running or some things are not working. We should have traffic. We should be getting data. Why is it suddenly quiet here? Please notify me. So there are times you may want to set notifications for insufficient data. But as you can see, we're working with in alarm state, and we're going to create a new topic because we don't have any SNS topic set up. So we're creating a new topic, and the topic, I'm using the name that they put here, and the email endpoints that we received the notification is what we're meant to set here. We can put our email. Yeah, okay. So asap@adedegal.com. That's what I'm putting there. And we create topic. So that is the configuration that we have. Where is it? Here for our notification. You can have as many notifications as you want on one single alarm. You can, on this single alarm, you can add one notification for in alarm, one notification for insufficient data, one notification. You can have so many different notifications. It's up to you. I want to show you this SNS console, this topic we just created. This is what it looks like. So you can publish a message to the topic by yourself. You can use it for different services that you want. It doesn't matter. So here we have it. And I mean, you can explore Amazon SNS and see what you want to do with it. You can use text messaging, you can use notification for mobile, and you can also use email for your notifications and all that. So back to it. Here we don't have any Lambda action, we don't have any auto scaling action, we don't have any C2 action, we don't. All these things are different actions that you can configure for your alarm. So there are times that you set your alarm and you already know what you want to do to fix it. Like if this thing ever reaches this threshold, take action. I'm not waiting for your email. If the threshold for this EC2 instance CPU utilization is more than 75%, please launch a new EC2 instance automatically. You can set that here. In your auto scaling, you can set that here. In your system manager, whatever it is you want to set, you can configure actions on your alarms. So I think this is all that we want to do. We're not setting any other actions. Then we click next. Our alarm is networking workshop alarm. We shouldn't have a space. And I'm clicking next. So this is what we have set for our alarm, and we can create the alarm. That's all. So right now our alarm is in insufficient data. Remember, for our alarm notification, we only set it to take action when it is in alarm state. So nothing happens right now for us. It's just waiting for more data. Okay, it's in an okay state. That means we can look at it and see what's going on. It has some data here, as you can see. It's just really little, but it's very far from our alarm threshold. You can see the red line here is our alarm threshold. And yeah, everything looks good. So there's nothing else for us to do. Yeah, I need to confirm my email for it, but I haven't confirmed my email. Pending confirmation. So I need to confirm my email for the alarm notification. If not, it can't be sending. I mean, that would be spamming. But apart from that, that's all. And let's go. So there's VPC flow logs. Let me see. So we still have some time. We would need to do this. I don't know what would be the best course of action for us. I would just stick it out and try to finish these flow logs. You don't have to stay online. If you want to go, you can go off and then you can watch the rest of it later. But I think it's best for us to finish these flow logs so that we can just wrap up the foundational topics once and for all. And next week we can just do advanced topics. So I will stick it out and do the VPC flow logs. I hope to be done with it in like 15 minutes since we are not going to be doing much. Okay, so next will be VPC flow logs. So VPC flow logs allows you to monitor the IP traffic that goes through your VPC, going to and going out of all your network interfaces. Remember, anywhere you see network interface in your AWS account means there's an IP address there. That's why there's emphasis on going to and from your network interfaces, because they have IP addresses, and any communication between IP addresses in your VPC is going to be monitored and collected in your VPC flow logs. So you monitor the move of traffic within your VPC. Next, we can start to create a VPC flow log. So we're going to go to our CloudWatch console. That's where we are, but I'm going back to the beginning, Yeah, okay. And in this menu on the left, we're going to log groups here. Under logs, you see log groups. We're going to log groups and we're going to create a log group. Let me see the names we want for the log group. Networking workshop flow logs. That's a long name. So networking workshop flow logs group, okay? And it is set to never expire. Be careful of this. This is a workshop. I know they are like, just create it and set the name and then click create. Retention setting in real life, you don't want to set it as never expire. You want to set your retention to something that maybe 1 week, 1 month, depending on how much time you know that usually takes these things. Know your log retention and stick with it. Don't just create log and put never expire. It's going to sit there forever. All your logs are going to be collecting forever without being deleted, and they're going to cost you money eventually. So retention setting, change it to something that actually is realistic. But right now, for the sake of the workshop, we're just changing the name and leaving it as that. Okay. This log class, standard or infrequent access, also impacts your cost. Infrequent access is cheaper for storage, but standard is I don't know how to explain this without going deep into S3. There are different levels of storage in S3, but you save things that you use frequently in standard. Like the name goes, infrequent access, you don't use it frequently. But the thing is, with infrequent access, whenever you want to do it, I think it takes a little bit of time when you want to get stuff from infrequent access, or the cost of accessing it is a little bit more, but you don't get a lot of cost in terms of storage. So yeah, we create as is. So we have our log group already created. If you scroll down here, you can see it. There's the last one here highlighted. And now we want to create our VPC flow log. We're going to go to our VPC. Here, I'm going to check for VPC. Here we are. And for VPC A, that's what we're going to be using. So VPC A, I'm going here. And when you scroll down, in flow logs tab, in this tab you can see resource map, deciders, the flow logs. That's what we're going to. We don't have any flow logs in this region. I'm going to create a flow log. Okay, someone asked what this session was about. I'm sorry I didn't see that until now, but this session is about monitoring your AWS network. So we're looking at CloudWatch and VPC flow logs. Yeah. And I'll just write it here. This session is about monitoring your AWS network. Okay, so we're creating a flow log for the VPCA in our environment. And the name of this flow log is Networking Workshop Flow Log. I mean, that's not surprising, seeing what we've been naming everything so far. And the filter is all traffic. By default, I usually go with that also, because why monitor only accepted traffic, or only, there may be use cases, but this we're monitoring all. we're setting the maximum aggregation interval to 1 minute. In real life situations, you may want to change it to 10 minutes, but because we have, limited time with this anyway, so you want 1 minute intervals. So what this does is, in your flow log, there's there are log streams, and the way the flow logs, the I'm saying the flow logs, the CloudWatch logs, I would say the CloudWatch log actually is structured is like you have log group, you have log streams and all that. So depending on what you state as okay your maximum aggregation interval, it determines where okay it breaks off each chunk and stores it. So if you say 1 minute, you're going to have a lot of 1 minute chunks of data. And then if you say 10 minutes, it's going to be like 10 minutes chunks of data. What that means is you might have one chunk of like maybe really long records of stuff, but then you are able to have maybe lesser entries because a block of 10 minutes is one entry and that block of 10 minutes. So it's just, determine how frequently you want this to be logged. And the destination is CloudWatch logs. We have created our log group. Remember, we created that just now. And we're going to select it as our log group. So you could also send it to Amazon S3 bucket or whatever. Some people mostly use S3 buckets when they want to configure some analysis on it directly from there. You could also analyze from CloudWatch logs also, but that's another conversation entirely. But yes, you set destination as log group, networking workshop, flow logs log group, and we have the role. I think they already created a role here that we can use. Let me see. Networking workshop flow logs role. You can create and use a new service role. That's an option. It's going to assign what needs to be used for it. But we already have an existing service role, that's why we're using it. So it's nothing you need to beat yourself up over. If you're interested, you can go to the IAM console and check the permissions that were put on this role. That's just what is important. And the next thing after setting all of this is to create our log flow. I'm not using any other thing. The default AWS format, you can look at it. It's here. You can look at it. There's the account ID, the interface ID, that's the network interface, and the source address, destination address, source ports, destination port, everything that is important for you to log. You can have your custom format that you can define what it wants to write. You can say, okay, source address puts you can put text there and have it in a way you want, but just know that this is the default one that's going to be used. And we can create flow log, that's all. Okay, so we have here our flow log created, connected to the CloudWatch log group that we created for our flow log. And we can see, okay, now this is our VPC. Coming back to the flow logs, we can see here that we have flow logs for our VPCA, and we're collecting all traffic flow logs in that VPC. It's useful when you need to debug your environment. So we're going to generate traffic and we're going to be done. At least I think so, yeah. Generate traffic, review it, and you can look at it. It's just, but the main thing was that you know how to create the flow logs, and then we're going to look at how you can query it. So we're going to generate traffic. I'm going to, where is it? Do we really have the time to do the generation? Let's say go to the EC2 instance. You have to actually log into the instance and try and run some things. That's why I'm like, do we really have the time to? Where is it? We have between VPC A, private A, Z1 server, this one. I want to connect to it. And connecting to it, I want to use a session manager. So we're logged in here to the private AZ1 server, and we want to generate traffic between that one and the VPC-B private AZ2 server. No, VPC-B private AZ1. I mean, it doesn't really matter. VPC-B, this is this one. Let's see. Okay. So let's see. iPerf, where is it? I need to connect to this one too. Session manager. Okay, so this is the VPC-B, this is VPC-A. So I'm going to use iPerf. It's a tool, like they said, for networking stuff, I would say. For checking, for performance tuning, listening to each other and all that. Let me see. iPerf is not set up. This one too probably does not have iPerf. Let me see. Yeah. I'm not ready to start setting this up with this. But at least I could just ping them. I would just ping the instance. And that would at least do something with it. I'll just ping the instance. Let's see. Ping. It's probably not open for the connection. Let's have a look at the security group to see what it's allowing. The inbound rule is allowing all. Okay, on ICMP it's allowing everything, so it should work. Ten 10.1.1.100. Yeah. We have to wait. It's probably not going to work. Yeah, it's not connecting to it. And then we have, this is VPC-B private AZ1. Let's check our VPC-A private AZ1. Where is it? Let's ping it also. Okay, this one is able to communicate with the VPC. With the VPC, a private one. Okay. Just leaving it running for some things to at least communicate between them. Now let's go to CloudWatch and go and see what's going on there. Is CloudWatch. Okay, no, this is our alarm topic. Let's go to CloudWatch. I just want us to quickly wrap this up. CloudWatch, our flow log group that we created. We go to log groups, and then we go to our flow log group. Oh, we have some entries here. So these are from some network interfaces. ENI, Elastic Network Interface, in the VPC environment, and it's showing us what the last event is. You can also tail the log, so it's just going to be giving you like live update on what the logs are. I'm closing this so that we can see. This is the live tail of the logs, so we can see what's going on in real time with this. Let's see here, down here, let's see. Scroll to latest events. This is what it looks like, following the exact same let's open it. Following the exact same format that it said when we were creating it. That's how it is logging the flow logs. It will tell you the ANI. So no data. Let's see the time of the records. There's no source, destination, ports, source ports, destination port, source address, destination address, nothing. It's just this ENI doing some things. But as we can see, it's connecting traffic or the information on all the Elastic Network interfaces in that environment, regardless of whatever it is that they are doing with themselves, as we can see. And honestly, you don't want to have so much logs collected except if you need it. So try to change your aggregation interval time to 10 minutes instead of 1 minute. Have your retention time set to a realistic time, maybe maximum 7 days or 30 days depending on your use case. And then you also want to have only the data that you want to be collected. Maybe you don't need all. Maybe you need only accepted traffic. Maybe you need only rejected traffic. Maybe you don't need to set for all your VPCs. Maybe you only need for particular VPCs. Just know what you are selecting and make the best use of it. So we have this. And okay, this is what they're talking about, setting up iPerf. And we still need to do some things with the security group. We'll be going into that detail right now, but I think we have been able to at least set up the log groups properly, set up flow logs for our VPC, and we're able to work with it. Now this is running the iPerf setup that I said we were not going to go into because it's going to help you generate a lot more traffic, of course. And it's not yet set up. I tried running it, but you need to install it and set it up, so we won't be doing that right now. But it is something that you can still do if you want to install and run iPerf on your servers, and then you're able to generate more traffic that has useful information that will give you IP address, source destination, all that stuff, instead of the blank ones that we have right now. And yeah, I think that's what we're going to be stopping at for the monitoring. Oh yes, I also wanted us to query the flow log. We don't have right now a lot of useful data, but we are able to check log insights and know how we want to query these logs. So we're going to look at it quickly. So in our log insights, we want to go for our log group. let's see here. Should we select local group? The way this thing is, I think it's not very arranged well. Let me see. Yeah, I think this is better. I'll be switching between them here. So here we are meant to, this is, you can edit it to whatever you want. You can generate query to, like using like generative AI. But we're going to select the query down here. We need to select our logs. Come in, where is it? Log group. So you see select log group here, and we're going to select the networking workshop flow logs. That's what we want. And let's go down. Yes. So with this selected, we're going to click top 10 byte transfers by, let's go down here. This is all we want to check. Top 10 byte transfers by source and destination IP address. These are sample queries that are generated for us in this site, and we are able to check for it. So here, these are all the entities that we can filter in our log, whatever. Here, when you edit this, you can change it. Say, okay, interface ID, log status. These are details, source address, source ports. You can customize what you want to check, filter in your fields. But you can also use sample queries here, like saved and sample queries. You check VPC flow logs, and then you can go. These are sample queries for different use cases. You can see there's Lambda sample queries and all, but we're using VPC flow logs. So here we're going to look for the top 10. There was the one that they told us that we should use. Return the top 10 byte transfer by source and destination IP address. That is sample log. That is sample query we want. And when you click it, you can see how it is written. You can copy it and paste it here. You can just click apply, and it's going to put it here for you. So you can see it here now. It has replaced what was there before. And that's how these sample queries worked. You can also save queries that you want to save. Like when you customize the query that you really want here, you can click save and have it in your saved and sample query. So you don't need to keep it in your head. When you find the results that you want, you can just save it. You can generate a query and then you save it. That's how it works. So you run the query, it gives you the answer, and then that's all. For us, I don't expect us to have something really cool like the numbers they have here, but we have some numbers, and we can see it in our chart here, all the different source addresses and how they are comparing to each other. And here is because we have by source address and destination address. So everything is here, source address, destination address, the bytes transferred, they're all here. And here, okay, I see it's the time when they ran and how much bytes was transferred at that time. So we have all of that, and we are good to go. Alarm notification. When you follow the iPerf installation and all, part of the traffic that you generated should have triggered your alarm, because there was one situation where they triggered beyond the threshold that you set. So you should get an alarm if you set it up properly. And this is where we're going to end it today. We're going to wrap it up now. I'm very happy that we actually got to finish the foundational part of this networking workshop. It's been a long time coming. When I opened this networking workshop for us to work on it, I was thinking we'll just do it in one week or 2 weeks, because I try not to do any of this alone and make sure we do it online together. So maybe that's part of it, because if I did it all through before by myself, I would have known that it would better to break it down into different aspects. But I'm happy that we are getting to touch on very important topics in the AWS environment, and I look forward to seeing you again in our next session, where we'll be going for the advanced topics straight to AWS Gateway Load Balancer, and I look forward to that. Thank you. Bye bye. Don't forget to clean up. There's instruction to clean up in this particular module, and it will help to make sure that you don't incur any costs that you're not expecting. If you need any AWS credits for your deployment and the things you're working on, you can drop a comment. I would try to reach out to you some way. I also post some AWS credits in my account and in the WhatsApp channel where people follow this series. So I mean, each one is like $20. So like last week, I posted like 5 of them, and some people were able to make use of it. I look forward to seeing you. Bye bye.